horizontal asymptote is y equals 0. So it's that horizontal line at y equals 0. What if we had like g of x equals 6x squared minus 3x plus 4 over 3x squared minus 2? So again, we want to look at what happens when x gets really, really, really big. So as x goes towards infinity, again, those leading terms, so the term with the biggest exponent is going to dominate everything, which means we don't even have to worry about the other terms. So this function is going to tend towards x squared divided by 3x squared, which is what? What is it?
It's 2.
It's just 2, right? The x squareds cancel. And 6 divided by 3 is 2. And so what that tells us is that as x gets really, really big, the outputs of this function are going to look like the horizontal line y equals 2. And so we have a horizontal asymptote at y equals 2. Let's do h of x equals, I don't know, 5x to the third. I don't even want a 5 there. X to the third minus 4x, and then x plus 2. So again, let's think about what happens as x gets really big. So my numerator is going to be dominated by x to the third, and my denominator is going to be dominated by x. And so h of x is going to go towards x to the third divided by x, which is what? X squared. And what happens to x squared when x gets really, really big? Sorry? It also gets really, really big, right? If you square bigger and bigger numbers, like if you square 1, you get 1. If you square 2, you get 4. If you square 3, you get 9, right? As you square bigger numbers, it gets bigger and bigger and bigger. So is there a specific number that x squared is going to get close to? There's not, right? Because it's just going to keep getting bigger. There's no what we call bound, which means there's no number you can say everything is below this. It just keeps getting bigger, and that tells us that there's no horizontal asymptote. Because the definition we gave for a horizontal asymptote is a specific y value that we get close to as our x values move towards the edges, right? So since we have no specific value asymptote, we have no horizontal asymptote. So these are our 3 cases. If we look at this first one, Shelby, what do you notice about the degrees of the numerator and denominator? Right, so which one's bigger? Yeah, the denominator, the degree of the denominator is bigger than the degree of the numerator. And it doesn't really matter how much bigger it is, as long as it has a higher degree, that tells us that the denominator is growing way faster than the numerator, right? Like, because if x is like 10 billion again, then 10 billion to the third is always going to be bigger than 10 billion to the second, right? 20 billion to the third is going to be bigger than 20 billion to the second. So as long as our x values are large, x to the third is always bigger than x squared. And so that tells us that the denominator of the fraction is always getting bigger faster, which is making the fraction itself get smaller and smaller and smaller. just like when we had that pizza and we're cutting it into more and more pieces. So our first case here is if the degree of the numerator is less than the degree of the denominator. Then our horizontal asymptote is y equals 0. Every single time. Because if the bottom outweighs the top, then the fraction itself gets smaller and smaller and smaller. Jesse, what can you tell me about this second case, about the degrees of the numerator and denominator? So remember, degree is the exponent. So what's the degree of the numerator?
2.
And the denominator?
3. I don't know.
It's so, we're looking right here at exponents.
6 and 3.
The exponents.
Oh, 2.
Yes. So they are
Same.
the same. So if the numerator and denominator have the same degree, then these variable parts are just going to cancel, right? And so we'll always just be left with a constant here. And whatever that constant is going to be the y value that our function is approaching, just like here it approached 2. So if the degree of the numerator is equal to the degree of the denominator, then our horizontal asymptote is y equals the leading coefficient of the top divided by the leading coefficient of the bottom. Whoops, I forgot an O. So the leading coefficient is just the numerical factor of that term with the biggest exponent. So here our leading coefficients are 6 and 3. So I think in your summary it helps to put a little example here because the wording, it's kind of hard to describe in words. So like if f of x was equal to 4x minus 7 over 3x plus 2, then our horizontal asymptote would be y equals what? 4/3, yeah, because the biggest, or the degree of each of those is 1, right? So the leading terms are 4x and 3x. You divide those, and you get 4/3. So 4 over 3. And then we have one other option, blue. What can you tell me about the degrees of the numerator and denominator here? Yeah, the top is bigger than the bottom, which means that the top is going to outweigh the bottom. So the top will always be bigger than the bottom, which means that as x gets big, that whole fraction is just going to get huge, right? If the top is always bigger. So if the degree of the numerator is greater than the degree of the denominator, then there is no horizontal asymptote. It just doesn't have one. There's no specific value that our, or there's no specific y value that our function will approach as our x gets really big and really small. So you can just memorize the 3 cases, or you can make the ratios that we made here. Just do leading terms of each and be like, what happens when it gets really big? Either one of those will tell you your horizontal asymptote. If you want to just memorize well. So 2 other characteristics we're going to find are our intercepts. Alex, how do you find the x-intercept of a function?
Set everything to y, or set the equation equal to y.
Uh-huh. And what is y going to be?
Oh,
0,
0.
yes. So you're going to solve your output equal to 0, right? This is nothing new. The way that we find the x and y intercepts of a function is the same no matter what type of function we're using. So way back when we started with linear functions and we found the x and y intercepts by plugging 0 in for x and 0 in for y, that process has not changed. It's the same no matter what type of function you're using. So it's always the process for finding x and y intercepts. So finding the y-intercept, where am I? Savannah, how do you find the y-intercept?
Plug 0 in for x.
So we just evaluate f of 0. So one thing to keep in mind is that vertical and horizontal asymptotes are always given as equations. So x equals something, y equals something, and then intercepts are always given as ordered pairs, right? So like 2, 0, 0, 5. So let's look at an example and see how we can use all of these 4 things to graph a function. That's not the one I want. This is the one I want. Let's do, oh, I don't know. Let's find something fun. How about f of x equals 3x squared minus 3 divided by x squared minus 9. So the first thing you always want to do is factor the numerator and denominator completely. Because we'll find that finding some characteristics is easier to do with the factored form, and some characteristics is easier to do with the simplified form. So I always just write them both at the very top, and that way I can use whichever one is most convenient. So this is going to be 3 times x plus 1 times x minus 1. And this is going to be x plus 3. Times x minus 3. So our goal is to find the vertical asymptotes, the horizontal asymptotes, the x-intercept, and the y-intercept. So we'll start with vertical asymptote. How do I find the vertical asymptotes? Colton.
Take the denominator and put the 0.
Mm-hmm. So it is most convenient to use the factored form in this case, because then we can just set each of those factors equal to 0. So we have x plus 3 equals 0, and x minus 3 equals 0. So x equals negative 3 and x equals 3 are my vertical asymptotes. So I'm just going to start a list up here. And again, notice that those are 2 separate equations for 2 separate vertical lines. We cannot write this as x equals negative 3 comma 3, because we're not listing specific x values. We're actually giving the equation of a vertical line. And let's find our horizontal asymptotes next, or tote next. Horizontal asymptote. Where am I? Megan, how will I find this?
You use the first one and it just be 3 because the 2 x squared cancel each other.
Right, good. So that the degree of the numerator and the degree of the denominator are the same, right? So we have degree of the numerator is equal to the degree of the denominator. So y just equals 3x squared over x squared, which is equal to 3. So we just take those leading terms, and that gives us a horizontal asymptote of y equals 3. You want to think of these just as like small problems. So these can be a little bit overwhelming if you try to look at the whole thing all at once, but we're breaking it down into like 4 smaller pieces. So try to just approach each one like one at a time instead of like trying to think of it all at once, because it can get to be a bit much if you try to think of everything at once. But we have little ways of finding each thing that we're looking for. So x-intercept. Where am I? Chloe, how do I find my x-intercept?
You solve fx equals 0.
Right, so I'm going to use, nope, I'm not going to use that one. I'm going to use the factored form. And that's 3 times x plus 1 times x minus 1 over x plus 3 times x minus 3 equals 0. So notice that if you clear fractions here, the right side is always what? 0, right? If you multiply 0 by anything, you get 0. So if I multiply both sides by my denominator, I'm just going to cancel it on the left side. And then on the right side, I'm just going to have 0. And it actually turns out that if a fraction is equal to 0, then the numerator is equal to 0. Which if you think about it, like if you think of division of fractions as division, like if you have 6 divided by 3, so if you have 6 people, you divide them into 3 groups, you get 2 people in each group. Well, if you have nobody in any of your groups, how many people did you have to start with? 0, right? So the numerator has to be 0 in order for that quotient to be 0. You have to start with nothing in order for there to be nothing in every single one of your groups. And so you can actually do this just by setting the numerator equal to 0 immediately. If you're not comfortable with that, that's fine. Just clear fractions and you'll end up with the same thing, because when you multiply on the right side, you always just get 0. And so now we can set each of our factors equal to 0. Whoops. So we get x equals -1 and x equals +1. And so that's -1, 0, and 1, 0. These are intercepts, so they're specific points, right? They're ordered pairs. They're not equations like we got with our vertical asymptotes. So our x-intercepts are -1, 0, and 1, 0. Garrison, how do I find my y-intercept?
You evaluate f of 0.
Which means what?
So plug 0 in for x.
Yep. So f of 0, and using the simplified version works best here because all the terms that have x in them just become 0. So if I do 3 times 0 squared minus 3 over 0 squared minus 9, well, everything that has an x in it just becomes 0, and you're just left with your constant terms. So you have negative 3 divided by negative 9, which is 1/3. So my y-intercept is 0, 1/3. So now we have everything we need to sketch a graph of this function. I'm going to erase everything but my little list when everybody's done writing. We all good? Okay. So let's sketch a graph. It's kind of cool because these graphs are somewhat complex, but just knowing these 4 things gives us enough information to know what the graph looks like. So where's my graph paper? First, we're going to draw our asymptotes, right? Which, again, are lines, right? So we have a vertical asymptote at negative 3. And we use dashed lines because these aren't actually points like on our graph. They're kind of like fences, right? They create boundaries for like where parts of our graph begin and end. So, and then we have one at positive 3. And then we have a horizontal asymptote at positive 3 as well. And so now we're ready to start drawing the points on our graph. So the first one, I have negative 1, 0, and then 1, 0. And then I have 0, 1/3. So now we're ready to sketch the graph. On the left side of that vertical asymptote, there's 2 options for what my graph could look like. It can either go like this, or it can go like this. Anybody have an idea of which one it has to be? Top or bottom? Top? Why?
Because the leading coefficient is positive.
So you're right, it is the top. But it's not actually because of the leading coefficient. So it's tempting to try to think of this like we did with polynomials, like it opens up or down because of the leading coefficient. But because even though these kind of look like polynomial functions or quadratic functions, they don't actually work exactly the same way because of the leading coefficient. Because we could have like some of our factors could be positive or negative. Like the reason the leading coefficient determines the way that a quadratic opens is because x squared is even, right? And so it's always even, or it's always positive unless you're multiplying it by a negative number, in which case it's always negative. Whereas that's not necessarily true here. When we divide x squared by x squared, both of those are positive. But then what happens in the other terms is going to determine the sign of the rest, right? Because we can't just look at the first terms here because we're not on the edges. Anybody have any other idea why it might have to be the top one? What's up?
Because on the bottom there'd be another x-intercept.
Yeah, so one thing about finding x-intercepts is you're not just finding 2 points that are on the graph. You're also finding that there can't be any other points on that x-axis, right? If we had an x-intercept at negative 4.5, we would have found it when we found our x-intercept, right? I'm not allowed to cross the x-axis right there. I am only allowed to cross the x-axis at those 2 points because those are the only 2 point or x values that make my y value 0. And so in this case, I know that my graph has to look like that because I'm not allowed to create new intercepts that I didn't already find. So, boom, boom. What about in the middle? So I will give you 2 options. There's actually 4 options, but we'll just go with 2. It either goes like this or like this. Which one is it? Yeah, it's down, right? Because that's the only way to get through those 3 points. It's also like it could go like this. But you guys all see that there's no way I could get through those 3 points that way, right? Because if I did that, I'm only crossing the x-axis once. So I have to cross it twice. And if my y-intercept was down here, then it would open up. But in order for me to get through that y-intercept up top, it's going to have to look something like this. And then on the right, oh, it's almost time to go. On the right side, it's going to look like this as well because I can't go through the x-axis. Again, just like what we talked about on the left side. So what you guys are going to do tonight on your homework is you're just going to be doing matching. So you don't actually have to draw the graphs yourself. You're going to be given like 4 options. So you'll find the 4 characteristics and then just match them to the correct graph that has those 4 characteristics. Some problems are a little funny because they ask about something called a slant asymptote, which we're not covering, but I've given you the answer. Like it says, like, click here, it's the right answer. All the problems are like multi-part, so I couldn't ask the questions I want to ask without having the other part in there. So I just gave you the answer to the part that we don't care about. You'll learn about those next semester if you take pre-calc.
It's just M1 now.
Yes, we just have my math lab tonight.